Hey, what's up, guys? This is Jung here again. So, let's quickly take a look at today's daily challenge problem number 565, array nesting, right? So you're given like an integer arrays, right, nums, where the numbers is a permutation of the numbers in the range of 0 to n minus 1. So it's a permutation. So which means that, every number is unique, and it's guaranteed to be in the range from 0 to n minus 1, right? And then your task to find a set, right? A sequence of number where each element, basically, as you guys can see, so the first one, the first element will be starting from a single number, right? But this number is not fixed. We can start at any number, right? And starting from here onwards, so we basically will be use the value of this number as an index to find the next number, right? That's why we have a nested here, like nums k, nums k, and then nums k, right? Until we have seen a number we have visited before, right? And then we need to return the longest length of a set, right? Yeah. So for example, we have this one here. Basically, we can start from the first one, right? So we have 5, 4, 0, 3, 1, 6, 2, right? We start from 5, okay? We start from 5, and then the next one will be a number in the index 5, which will be what? Which will be 6. Which will be 0, 1, 2, 3, 4, 5. Yeah, it will be the first one will be this one, right? And then the next one is what? It's nums 5, which is 6, right? So from 5 we have 6, right? And then from 6 we have 2, right? So from 5 we jump to 2, and then from 2 we jump back to 0, right? So from 0 we back to 5, right? That's when we stop. And as you guys can see, we have what? This is going to be a 1, 2, 3, 4, right? We have 4 unique numbers in this one, right? Instead, if we start from 4, right? So let's say if we start from this one, right? So it will be like 4 to 1, right? 4 to 1 and 1 and 1 to 4, basically. Yeah, 4 to 1 and 1 to 4, right? Which is 2 in this case. And for this one, if we jump from 3 here, it will be what? 3, it will be pointing to itself, right? So basically this is going to be only 1. So now that's why we have 4, answer 4 in this case, right? And here's the constraint, right? 10 to the power of 5. I mean, so a brute force way to solve this problem is obvious. It's easily just try to pick any number as a starting point, right? And then we'll basically try to loop through, right? We'll try to loop through the until we have seen a visited set, right? And then we stop, and then we get the maximum among all of them, right? But that one, it's going to be a n squared time complexity, right? Because we need to try each of the number, and for each numbers, we'll take O of n time to find the length, right, of that set, and that will TLE. And how can we improve that, right? I think the one of the observations we need to make here is that since the number is within the range, okay, and it's a permutation from 0 to n minus 1, it means that no matter regardless of which number we start with, it will always end up in the circle, right? For example, so in this case we start from 5, right, and then we go to 5, 6, 2. Let me remove this this one here. In this case we start from 5, right, and then we go 6, 2, 0, and then 5. This is a circle, right? So if we start from 0, right? From 0, we'll go to 5, and then go to 6, 2, and back to 0. So also a circle. Same thing for 6 and 2. Right, so this will tell us, you know what, basically as long as we have seen this circle once, right, then we don't need to, let's say we try 5 here, right, and then we go to 6, 2, 0, and next time if we are trying to start from 0 again here, we don't need to do it again, because we know, okay, 0 is a part of the previously visited circle, and starting from 0 or starting from 5 or starting with from any of the node inside the circle will always end up with the same length, right? So that's how we improve our performance, right? By marking the nodes we have visited before in this circle uh, to be visited, so that we will not visit it again, right? So that's the basic idea to solve this problem. And let's start coding then. We have n is going to be the length of nums, right? And I'm going to have like scene array here, right? Everything it's the and then the answer will be 0, right? So we basically start from any of them. We try to loop through each of the numbers, but in this case, you know, we have length, right? That's going to be the 0. I'll just use L here. So we try this number. We check if this one has been seen before. So we can do something like this. So while not seen number, right? And then we do what? We mark this scene. We mark this number to true, right? And then we increase the length by 1, right? And then next time we'll just keep doing, right? It's going to be a num equals to nums.num, right? Basically, next time we'll be using the value of this number as an index for the next number, right? And then here we have the answer going to be the answer, the max of the answer dot count, right? And then in the end we return the answer. So that's it, right? I mean, sorry, length, yeah. Yep. Because now, as you guys can see, since we have this scene array here, each element or each number will only be visited once, right? So which means time complexity for this one is going to be O of n, right? Because the next time when we try to visit the number we have visited before in the previous circle, then we'll simply stop from here, right? And this answer, this length will be 0, right? And it will not be be recalculated again. And yeah, I think that's it for this one. Yeah, pretty straightforward, right? We just need to observe, right? Observe basically every visit or every process will end up with a loop, okay? And any number in that loop will end up with the same length, right? So that's the only thing we need to know here. And there you go. Okay, cool. And thank you for watching this video, guys, and stay tuned. See you guys soon. Bye bye.